Welcome to AP Calculus, Definite Integrals Part 3, Separable Differential Equations. Alright, here we go. You're going to take some notes here for a couple of screens, and then we'll go into examples. Alright. Go ahead and write that down. And then I'll move on. Having a little technical difficulty right now. Sorry about that. Go ahead and write that down. Here are the 4 steps you need to do in order to solve a differential equation. And then we'll move right into an example. Ready? Probably not. Go ahead. Write it down. Alright, here's our separable differential equation. And we have an initial value, so we can substitute in and get our C. So here we're going to get everything we can on one side that has X or maybe a constant in it. Okay, we've now separated it into Y's on this side, Y's and X's on that side. Okay, now we're going to change Y prime to dy dx. Multiply both sides by the differential dx. So y squared dy equals x dx. Now we're ready to integrate both sides. Okay. That would be y cubed over 3 plus some constant, because this is an indefinite integral, equals x squared over 2 plus another separate random constant. So now we're going to combine these two like terms, the two constants, which will give us a third arbitrary random constant. Just subtract C from both sides. You'll end up with C over there, because these are not necessarily the same size, and we'll figure out this size after we get done solving. Alright, multiply both sides by 3. 3x squared over 2 plus C. Of course, when we multiply that constant by 3, it's just going to make another random arbitrary constant. Take the cube root of both sides. Y equals cube root of 3x squared over 2 plus C. Now we're ready to use that initial value at the top. Y of 0 equals 3. So 3 equals the cube root of, let's see here, 3 times 0 over 2 plus C. 3 equals the cube root of C. That would have to be 27, right? So C equals 27. So therefore, our function was y equals the cube root of 3x squared over 2 plus 27. There. We've solved that function for y. Alright, here's our next separable differential equation. We need all the y terms over on this side. So divide both sides by y. 1 over y prime, 1 over y prime equals 6x. 1 over y dy dx equals 6x. Multiply both sides by the differential dx. 1 over y dy equals 6x dx. Now we're ready to integrate both sides. So that would be the ln of the absolute value of y plus c equals 3x squared plus c. The ln of the absolute value of y equals 3x squared plus c. Exponentiate both sides. Okay, this is where it gets a little tricky. Y equals e to the 3x squared plus c. So y equals e to the 3x squared times e to the c. All I did is rewrite these, so these two exponents are being added. So I wrote them as the same base. The two bases being multiplied together. That's the same thing as adding the exponents. This e to the c will be some random arbitrary constant. So we're actually going to change it to c e to the 3x squared. Now we're ready to use our original value. Y of 0 equals -1. So -1 equals c e to the 0 power. C equals -1. So our function is y equals -e to the 3x squared. And that, my friends, is how to do this. Alright, let's move along. Alright, so now that we have separated it, we can differentiate. Here we go. This is y to the -2. So that would make this, add 1 to the negative exponent. Add 1 to the exponent and multiply by the reciprocal. -1/3 y to the -1. We'll just put that y in the denominator, plus an arbitrary constant, equals 2x plus an arbitrary constant. Subtract c from both sides. -1 over 3y equals 2x plus c. Yes, these are all different c's. All these constants are different. Alright, now we're going to go ahead and reciprocate. So -3y equals 1 over 2x plus c. Divide both sides by -1. 3y equals -1 over 2x plus c. Divide both sides by 3. Y equals -1 over 6x plus c. Now we're ready to use our initial value. Y of 1 equals 1/6. So 1/6 equals -1 6 plus c. Okay, we need this to be a -6 in the denominator. So let's see here. Or you could just cross multiply as well. 6 plus c equals negative 6. Subtract 6 from both sides, c is 12. So the original function was y equals negative 1 over 6x plus 12. Alright, this does conclude AP Calculus, Definite Integrals Part 3, Separable Differential Equations.